Hello, here in Chapter 8 we are performing hypothesis tests. And the structure that we're going to study in this chapter is something we're going to build on in future chapters. So it's really important and fundamental that we really understand this process. And so the first section that we're looking at is going through the basics of this process. What is hypothesis testing and how do we interpret the results that we get when we perform a hypothesis test? So our goal will be to make a decision about a population proportion or a population mean based on a sample proportion or a sample mean. And this will be using probability. And so relying on some of the tools that we've developed so far in previous chapters. In Chapter 7, we got an introduction to inferential statistics, where we were able to get an idea of how accurate our estimate is by building an interval around that estimate that would hopefully capture the true proportion or the true mean within that interval. But there was some aspect of uncertainty involved with that. So we're going to explore a slightly different approach in Chapter 8, where now we're given a claim about a parameter, and we want to test whether or not that claim is true. But really, what we're really testing here is we're going to assume that that parameter is what it is, and then we'll use sample data that we've collected to determine whether or not the sample we got would be likely or not under that assumption. Okay, so those are the main pieces that we're going to be looking at. The first is that we're going to make an assumption about reality. And this is in the form of a statement that's called our hypothesis. So we're going to state the hypothesis. And this comes in two forms. It'll have what we're calling the null hypothesis and the alternative hypothesis. Okay, and then once we've stated our hypothesis, that'll be essentially the assumption that we're making about our parameter. And then we're going to collect some data from a sample. So we'll sample our population, and we'll compute some statistics that go along with that sample. Okay, and so we'll compute in particular a point estimate, which, depending on if we're talking about a proportion or a mean, we'll compute p hat or x bar. And then from that, we want to determine whether it contradicts our assumption. So we'll try and answer the question, how likely is that point estimate given our assumption? And that's where probability comes into play. So how likely is that point estimate under the given assumption? And we won't be 100% certain, but what we'll be able to tell is if the sample data that we've collected is going to support our hypothesis or not. Okay, so depending on how that sample data comes out, it could be in support of what our hypothesis is or not. And yeah, we'll go into a lot of detail about how to make that judgment call at the end and how to interpret the result that we get. Now, the first step for any hypothesis test is to state the hypotheses, and this comes in two pieces. We've got the null hypothesis, which will denote H0, and the alternative hypothesis, which will denote H1. So the null hypothesis is really a statement that there's no change in the parameter that we're trying to make a statement about. So a statement of no effect or no difference and is assumed true until evidence indicates otherwise. Okay, and this will always involve an equals sign. Okay, so our null hypothesis will always be stated where I have some parameter equal to some number. So it always involves an equal sign. The alternative hypothesis is the alternative of what would occur if this were not true. In other words, if our null hypothesis were not true, what would be the alternative to that statement? So a statement that we're trying to find evidence to support instead of our null hypothesis. And depending on the way that this is stated, now notice that our alternative hypothesis is, in a sense, it's going to involve sort of a different symbol than what we have here. When we're performing the test, it's important that we look at the form of our alternative hypothesis, where it'll involve one of these three symbols. It'll involve either a less than symbol, so our parameter is less than some number, and usually it's going to be the same number that we have here. Or it's greater than some number. And the other possibility is that it's just not equal to that number. So it could be one of these three possibilities where involves some sort of inequality symbol. And in each of these three cases below, we're going to visualize maybe in each of these graphs below exactly how we're calculating the result that we're going to use to interpret the hypothesis test. So in what we're calling the left-tailed situation, this is when we involve the less than symbol. So for our alternative hypothesis, if we have it's less than some number, then we're computing the area of this region here, and that will tell us what we're using for our p-value. Depending on what that p-value is, it'll tell us whether or not we have enough evidence to support our alternative hypothesis or not. In the two-tailed case, we'll be using the not equal to symbol. And in this case, we're doubling the area of that region. And we'll see that the sum of those two regions will be what we're calling our p-value. So this one always involves the not equal to symbol. And then the right-tailed case will always involve the greater than symbol. And so in this case, we're writing our alternative hypothesis in the form of our parameter being greater than some number. And the area that we find on the right tail will be what we're using to compute our p-value.